Good afternoon, judges. We are Team 51, Lobang Infinity, and this is our project for LifeHack 2025 Knowledge and Collaboration, Topic 1. So, the problem statement given to us was that traditional learning systems often adopt a one size fits all approach, leaving students who learn differently or at varying speeds behind. Now, our solution to this is known as Eduverse. So, Eduverse has a key underlying principle that since no two students are the same, why should lessons always be the same? So Ediverse essentially adapts the lesson difficulty dynamically, personalizes content using visual, auditory, and kinesthetic means, continuously assesses progress and learning needs, and also is modularized, meaning that teachers can simply drag and drop topics in to create their own lesson plans. This is because when we deal with different regions in the world and different curriculums such as IGCSE, IB, or Cambridge A levels, there are different topics. Even though the topics are all relatively similar, some topics may not be included in other syllabuses, or some topics may be omitted. In this case, teachers often have to supplement their own learning plans and reorder lessons accordingly. The tech stack we used was Next.js, which is a full stack React framework, and Supabase as the back end and authentication, and hosted it on Cloudflare. Now, the student and teacher credentials are all recorded in Supabase, which is a relational database, and it is also stores all the question and learning information. Now, the key AI model powering this is the DKT, or Deep Knowledge Tracing model from PyTorch. And this was exposed via a fast API endpoint to our Next.js project. And the DKT models were trained on real life data. The AI model in question was known as deep knowledge tracing, and in essence, it is a LSTM based recurrent neural network. And what it does is, for a given set of observations or interactions with the problem set, which we call maybe problem 1 to problem 0 to problem t, or x0 to xt in this case, what the model does is it predicts the student's probability of getting the next interaction xt plus 1 correct on a scale from 0 to 1. Now, in this case, we can assess exactly how well the student is learning or how well the student is not learning, and therefore dynamically adjust the difficulty firstly, and also adjust the content revision type. So in this case, what it does is that it predicts this probability and is exposed via an endpoint to our model. Now, the parameters that it takes in are firstly the question ID, the correctness, which is just a binary value 0 or 1, because all the questions in this Eduverse are multiple choice questions. And lastly, it takes in the confidence level of the student, which is also reported by the student while answering questions. And lastly, the difficulty on a scale from 0 to 2, 0, 1, and 2 indicating easy, medium, and hard. Now, this is just a pedagogical research that was done, which shows that kinesthetic, verbal, and visual modes all complement one another and exhibit much higher retention than just visual learning. So how the model works is based on the model's prediction. What happens is, if it drops below a certain threshold, it displays revision notes, which are maybe like lesson notes that the teacher uploads, which are a visual mode of learning. Afterwards, if the learning further drops below a second threshold, it then reverts to revision using the video lecture before proceeding to the next questions. And lastly, if this does not work, means that the visual and auditory modes are both exhausted, it finally reverts to using interactive animations, which are embedded using iframes. These animations can either be contributed by the community or by the teacher themselves, or can be found publicly available. And lastly, if all of these fail, this indicates the student has a fundamental um, misunderstanding of the concept and has weak foundations. So in this case, what it does is it reverts to the previous linked topic. Means that, let's say we have topics like a recursion. If a student does not understand recursion, it means that they probably have a fundamental misunderstanding of functions itself. So it reverts to this topic. So now for our demo, this is how it works. So it begins with login authentication, and the teacher can log in using an email and password. So after this, the endpoints are all secured so that there's no cross-site reference forgery. And once the teacher is here, the teacher can create a new class. So this new class basically allows students to join using a 6-digit code. And what happens now is that once the teacher creates this code, they have an option to firstly create a lesson flow. A lesson flow is basically a set of topics. Now these topics range from anywhere from physics to maths to chemistry, biology, and so on and so forth. And what they can do is simply drag and drop these topics into a weekly timeline. Now, after they complete this, what happens is they can now join these together, because the compute like our program does not know that recursion, that functions is a prerequisite for recursion. So these links are made by the teacher indicating which topics are prerequisites for the others and which topics will be reverted to in case the student has foundational weaknesses. And finally, the student can now go, okay, now the teacher, before the student joins, the teacher needs to also upload learning materials. And what happens is and what happens from here is that, for example, taking recursion as an example, the teacher can drag and drop PDF notes, YouTube video URLs, and embedded animation links. And after this one, they can also save the material such that this students can access them. Now, from the student's point of view, they can log in and join a class. And once they join a class, they can access the notes, the videos, and the interactive animations that the teacher uploaded. So this is before the teacher has uploaded an assignment. Now, once the lesson is complete in class, the teacher can now upload an assignment. So for example, first when they create an assignment, they can put an assignment title, due date, and filter by module, institution, and topic. They can also create custom questions in case the question bank is not sufficient. So once they complete filling up the fields and indicating the correct answer, it gets saved over here and they can create this assignment. Now, all that's left to do is for the student to do the assignment. Now, first of all, let's say the student gets a question wrong. This drops the model's prediction below the threshold, causing them to revert to the PDF notes. If they get another question wrong, what happens is that it drops below the threshold again. This is a simplistic threshold that has been arbitrarily set such that it demonstrates the reversion to the threshold, and it will be more obvious in case of longer problem sets. But now if they still get more and more questions wrong, what happens is finally this it has reverted to functions, which is the prerequisite. What happens now is that once they answer the functions questions correctly and achieve a sufficient threshold, they move back on to the recursion questions, and once they answer, the quiz is then finally completed. So essentially, they are not assessed on how well they are able to score, rather they are assessed on their understandings. So now the data is all anonymized and it's all logged securely with only row level security enabled. And another future for the future of Eduverse, what can be done is the implementation of gamification to allow students to enjoy learning more. So in this case, thank you for